Thanks. All right, so as it says, I'm Jimmy Berry. I'm going to be talking about DevOps. This can mean a lot of different things, so I'm going to focus in on a particular one. So we're going to learn some prerequisites that I think are helpful for kind of like navigating the space. So there's a lot here, so you can kind of imagine it like icebergs. We're going to be like jumping across the top of some, maybe peek under the water once in a while, see some stuff, but definitely not going to cover everything.
Are you recording your screen?
No,
Can you record your screen?
I don't think I have anything set up to do that.
Okay. SE System 76, is it no?
Is it what?
Is it no? Are you ready no?
It's KD, yeah,
Oh,
Plasma.
KD,
So anyway, so our goal for today is going to be to go ahead and deploy a TypeScript application to Kubernetes. We want to manage everything as infrastructure as code, so we can keep it neat and tidy. And we'll try and automate the process using Gitlab CI. All these things are applicable to, we're doing the same things you can do a million other ways. So we'll be learning kind of the concepts, and at the end, we'll peek at trying to optimize some of it. And to do that, we'll have to kind of like dig into how some of this stuff works. So as I alluded to, the goal here is to kind of like understand how the pieces fit together. So at some point in the future, if you're thinking about stuff, you're like, oh yeah, I think there's a way to do this. You can go look it up and figure it out. Just kind of like have things in your mind. But there's definitely going to be some nuances here that I'm going to ignore, basically. So to get started, I'm going to discuss like an application that will be our goal to deploy. I debated making it really complicated and including some WebAssembly stuff from Paul's talk last week, but I ended up keeping it trivial. So it's very common requirements here. So we're going to have ingress over HTTP. We want access to an S3 storage bucket. We want to track our errors with Sentry, and we're going to distribute and deploy this application with a container. So we're going to have some basic inputs. So we need to wire in stuff when we create a bucket. We want to be able to tell the application what bucket we have, Sentry DSN, and we're expecting the application to expose itself on port 8080. So some basic stuff. This is like the most trivial server you could imagine. And it's basically just for us to verify that we actually wired everything up. So DevOps is kind of like, most of the time you're treating the application like a black box, and you're like worrying about literally everything else around it and not necessarily the application. So to start off with, everyone probably has heard the term container. So we're going to go ahead and just give it a little bit of definition here. So it's basically a way to package up code, all of its dependencies, in a way that's able to reliably run it on other computers in kind of like a very high level. You kind of think of it as a similar concept to a jar, FAR, or even a zip file if you want. So there's a bunch of code and stuff in it. It includes some metadata. So one of the things it has is a default command. So if you don't tell anything else, it will run that command on all the code and stuff that's inside of it. Again, these are nuanced, but there's a lot of like repositories to store them and distribute them from there. So at execution time, it's generally a Linux native thing. There's actually a whole bunch of kernel components that are coming together to provide what we consider to be a container. If you're running this outside of Linux, most of the time you're actually running it on a Linux VM, and the tools are doing their best to hide that from you, but that's what's happening. If you go ahead and run, we'll go ahead and run node version 2219 as a container. You can see here you get the standard node prompt that you're probably used to seeing. Quick explanation of the commands. You can pretty much use these for anything you're trying to run on your box, and they'll make it behave the way you kind of expect. So RM just cleans up after you. The I keeps standard in open, so node would otherwise immediately exit. And TTY just makes a lot of certain command line applications behave the way you expect. So you want to read up on exactly what these do, but that's kind of the gist here. There's some implied things here. So it's assuming that you're actually pulling this image out of Docker.io. It's also assuming that you're using the library namespace here out of Node, and then it's pulling that tag off the end here. So you can write this out very explicitly, but there's a lot of assumptions baked into that. You can imagine if you run -- version here, we print out the node version, so it would be equivalent to running that command there. You may look at that and kind of wonder what exactly magic is going on under the hood that when I don't say anything, it does node and version still calls node. So if we inspect the image here, we can see a very abbreviated version of it. The metadata includes that its default command is node, so if we don't specify anything, it's going to run node. But then it's something called an entry point, is this Docker entry point sh. So something to be familiar with. Most containers have something like this. They do magical things in them sometimes that are not quite how you'd expect the application to behave outside of a container. So it's kind of good to be aware of it, because sometimes it can fight you. So effectively, when we ran those last two commands, we were running Docker entry point node and Docker entry point version, and somehow we ran node both times. So if we go ahead and run the container and get a shell out of it, we can actually dump out what the entry point is. You can see it's a tiny little script here. It's basically saying if it's something that looks like an executable, go ahead and run it. If it's anything else, pipe it into node, and if it's node, I don't need to worry about it. So some containers have very intricate entry point scripts, and you sometimes have to be aware of them when you're trying to operate with them. One thing that I find you can easily trip yourself up on, Docker decided to use unusual terminology for things that are common across other system libraries. Kubernetes picked the standard terms, but an entry point is equivalent to what you normally think of as a command, and a command is actually the arguments. So if you override the command in Kubernetes, you're overriding what Docker would consider to be the entry point. So just something to kind of be aware of, because they made your life tricky there. So let's go ahead and try to build a container. So again, a bajillion ways to do this. The most common one that you've probably seen is a Docker file. The goal of our build here is to create a bunch of file system layers that are basically what comprise the container image. So world's simplest build here. We're going to start with the node image. We're going to copy in everything that's in the current directory into source, and then we're going to assume we had a main.js in there. We're going to set that as the default command. So when we run this, you're inheriting that entry point that node provided, and you're saying, I just want to run my main.js script. If we were to build that and run that, it would work as you'd expect. Obviously, once you got an image, you usually want to put it somewhere else so you can run it other places. That's kind of the whole point. To do that, you usually have to provide some sort of credentials to push. Here's some examples, just kind of like what you're expecting to do here. And so you can tag and push things to all sorts of repositories out there. So a slightly more complicated example for our application in mind here, this TypeScript application. We're going to go ahead and again start with the node base. We'll copy in everything in the current directory to source. We're going to pull in the dependencies. We'll even transpile the TypeScript, and then we'll set our default to be the transpiled file there. So just kind of an idea of the types of things you can do here. So before we get too far along, we'll jump into.
Quick question. On the build, I saw build X way back when. Is that the default now, or do you still have to do like Docker build X build to get the new version?
So the question is build X actually the default now, or do you still have to run it like that? Again, a fun, nuanced question. So if you run Docker build in newer versions, you are using buildkit, but you're using a slightly neutered version that doesn't have all the same features as if you run the buildx command. All the arguments are identical, so if in doubt, run buildx. But it's kind of fun. So anyway, so we'll jump into Kubernetes here. I'm sure everyone's probably heard of that term. You probably also heard of container orchestration. For our purposes, that's just going to be deploying, scaling, and managing the lifecycle of containers. There's obviously a lot more stuff we could talk about. I think Kubernetes has a pretty great ecosystem. You'll hear about like package managers and things. So you could imagine if you have your favorite CMS or something, there's probably a package out there to deploy the web server for it, the cache for it, database, and all of it, and bundle it together for you. There's all kinds of stuff. There's also some really fun developer tools. I'll have a quick shout out here to K9S if nobody's used it, but it's basically, I think of it like a better kubectl. So this is listing all the pods in a cluster. You can press shortcut keys and instantly start streaming the logs, jump into a shell in one, edit it, scale them up and down. It's pretty slick. So what is Kubernetes in practice? So when most people talk about it, they're really talking about a hosted control plane, which means that's your EKS, your GK, your LK, all the different cloud providers have their own, and they're hosting the control plane for you. What's everyone trying to do is they're actually trying to be able to say, hey, I want to run this container, and I don't want to think about it much more than that. So that's what you get. You're also going to be wanting to see all the things related to the container, like you want to be able to pull out the logs, you want it to automatically restart if it crashes, you want to say, hey, I want to update this thing once in a while, go ahead and spin up new ones before you destroy the old ones so I don't have an outage, all those kinds of things that you want to do that Kubernetes is kind of handling for you. So now you may say, what is the control plane? Sounds like a fancy word, right? It's effectively just a CRUD API for a bunch of resources, and Kubernetes has a thing called watches. Watches just mean you say, hey, I'm interested in this category of resource or this specific one or whatever it is, and whenever it changes, let me know, and that's all it is. This is backed by a highly available key store. In this case, it's etcd. Highly available here just means it's on multiple nodes, so if one goes down, it keeps working, and they sync and handle talking to each other. And then you have the kubelets, which are basically talking to the control plane to orchestrate what's happening on all the nodes in the cluster. So built into that control plane is usually these set of built-in controllers and resources. A resource, in this case, the most common ones you're going to bump into would be a pod, which is just a group of containers. Could be one. A deployment is a set of pods, so you could run 10 pods, which are 10 web servers, something like that. And a service is a way of saying, hey, I want a single IP and port to essentially load balance to a bunch of different pods. It's not exactly load balancing. Again, these are nuanced things, but it behaves that way for our purposes. And then a node would be a machine, which could be a VM, a bare metal machine, could be all sorts of things. So you may have seen these, but a lot of times Kubernetes resources are presented as YAML. So they have a version, a kind, and usually some metadata. So in this case, this is a namespace. So we're going to go ahead, if we ran that kubectl apply command there, we would end up creating app1 namespace. We could then create a pod inside of it. In this case, it'd just be a simple Nginx server, and we'd say, hey, I want to expose port 80 as, and you can name ports HTTP so you can reference them in other places. So that's all we're doing here. So a concept that we don't strictly have to understand, but I think is really useful, is labels. So Kubernetes uses labels for everything under the sun. They're basically just arbitrary metadata that you can attach to pretty much any resource. They can also be namespace themselves. So you can see some common ones there, like the app Kubernetes IO name. You can also make up your own namespaces. You can also skip the namespace entirely. So as an example, say we had a node that we're managing like physical hardware. This one has like a really big internet connection, so we want to put like network-heavy applications on it. We could label it with network fast. And if we added that as a node selector to the Nginx pod we created earlier, it would only put that pod on the node that has the fast label on it. So it could be more than one node, it could be only one, who knows. This concept is used repeatedly all over the place in Kubernetes. So in fact, a deployment basically just has a nested pod template inside of it, which attaches the label, in this case, app Nginx. And then the deployment itself keeps track of those pods by saying, hey, I'm going to match any of the pods that have app Nginx. So that's actually how it keeps track of them. Seems a little bit abstract at first, but it makes sense when you start kind of digging into how all this stuff works. Similarly, if you have a service, again, I select all the pods by saying, hey, they have the label app Nginx. So it's used all over the place. So controllers now, we said the control plane had controllers and resources. So a controller is doing that watch thing we were talking about. So anytime you change a resource, it's reacting to that. It can also do things on admissions. So you could say, like, I'm full, I can't have any more of these, stuff like that. So some of the built-in controllers here would be a deployment. A deployment just manages a set of pods. And then so you could have a replicas property on it. And if you increase it, it would create more pods. If you decrease it, it manages deleting some. Similarly, if you update the container image that you're running, it would manage the process of saying, OK, I have 10 pods running. You just updated the image. I need to bring up 10 ones with the new image and then delete all the old ones once they're gone. And there's different strategies and, again, nuance to that. But that's effectively what it's doing. Similarly, there's a cron job controller. Does as the name suggests, creates jobs on some sort of interval. And jobs create pods. Again, there's extra layers of abstraction here because there's fun things you can do with these things. Otherwise, they have the concept of an operator. And this is where you'll see a lot of proliferation in the Kubernetes space. An operator is basically the same thing as a controller. It just operates on custom resources, which means things defined outside of like Kubernetes itself. So anybody can bring these to bear. So here's some example ones. If you're not familiar, we'll take a look at min.io. Min.io is basically an S3 equivalent. So you can host your own, what do you call it, block storage, or bucket storage? Object storage, that's the word. So here we can say they defined this thing they call a tenant. So a tenant would be like for some department or a company, we say, hey, we want them to have a whole bunch of storage. They have this much space, this much things. There's all kinds of stuff you can do with these. One of the built-in ones that doesn't actually do anything if you create it in a default cluster is an ingress. An ingress would be a way for like configuring a load balancer, route traffic to your service, which obviously we're interested in. So in this case, I have a ALB one here, which is an Amazon load balancer one. So assuming you have a load balance operator set up in your cluster, this is effectively what would happen. As soon as you create that ingress, the operator is sitting there watching for it. It says, OK, hey, I got this new ingress. It's going to take the definition, turn it into some rules that apply to Amazon's ALB, upsert those rules against the ALB, and then if you send traffic to that ALB, it's going to figure out how to route it to those pods. So if we take a look at our ingress here, if I specify a host like app1example.com, anytime I have traffic for that, it's going to, and it starts with the path slash, so everything, it's going to route it to our Nginx service, which we defined with that label match to match all the pods that we have created. So kind of the gist there. So bunch of stuff to manage and get all the details right. So how do we actually go about doing that? So I will suggest to you OpenTofu. So Tofu is a fork of Terraform. They did the classic license change that made everyone mad. They're generally compatible. They both do have some features that are divergent. So if you stick to one, you're good, and otherwise you need to pay attention. But stuff you can do with OpenTofu, you can manage things from files on your local machine, Docker instance on your local machine, different platforms out there, cloud providers, everything under the sun. And the general idea is it's declarative. So you say, this is what I want. And then when you tell Tofu, you say, make it so kind of thing. And in order to do that, it uses what's called a three-way diff, which I want to impart upon you that it's a very powerful tool, which we'll dive into. So the other thing that sounds really boring is it lets you import stuff. So a lot of times you may walk into a new job and they've set up a whole bunch of infrastructure for you. And you're like, I want to manage this OpenTofu. Maybe it's databases that you can't delete. There's no way to like delete and recreate it with one of these tools. Whereas this just says I can import it and I can start managing with OpenTofu. So it really lets you refactor and do all kinds of crazy things that you wouldn't do otherwise. So OpenTofu, there's this concept of a provider. These are provided both like official ones and there's also unofficial ones for, again, everything under the sun. So you'd have like an AWS provider or Gitlab provider or something like that. Each one of them gives you access to resources and data references, and then you kind of collect them all in what they call a module, which has inputs and outputs. And we'll go into kind of some examples of all this. So to start off with, we'll look at a three-way diff. So I think I've heard people talk about resources getting orphaned and things, and so we're going to kind of explain why this works really good. So basically, it's diffing between the declared state of what you said you want, the last time you ran tofu, so it keeps track of what it did last time, and the current state of all the things. So if we contrast this with just using kubectl apply or literally any other API that exists that's basically doing an upsert, it's always going to be referencing based on the name or the ID or something. It's only ever going to insert or update that thing. It's not aware of what other, like if you totally rename it. So we'll walk through an example here. If I go ahead and create a namespace app1, first time I apply it, it's going to create it. If I go ahead and add some labels to it, it's going to update it. If I rename it, it's going to just create app2 and forget that app1 ever existed because it's just looking at the current state of the file and has no idea what it did before. So you can see that you can very quickly make a mess if you aren't careful. So by contrast, if you use Tofu here, we can create a namespace. You can create app1. First time we apply it, create it just like before. If we rename it, guess what? It deletes app1 and creates app2, exactly like what we want. And it does this because when you run it that second time, you're declaring that I want namespace app2. The previous state had app1 in it, so it knows it's responsible for namespace app1. And it checks out in Kubernetes and says, hey, it actually exists, so I'm going to go clean it up for you. If you were to delete that namespace in between running this, it would also be able to tell that, and it wouldn't worry about it because it was responsible for it, but it's gone now, so you won't get an error. So it's kind of a very nice pattern. The more you do this stuff, you'll realize that there's an order to a lot of things. Things have to exist before you can add things to them, those kind of things. OpenTofu handles that very nicely, so we'll look at an example here. So let's say I wanted to make a deployment from my server inside of a new namespace. Clearly, the namespace has to exist before I can create something in it. So you'll see here I reference the namespace app1 that I'm creating. And because of that implicit relationship, Tofu will always order it such that the namespace is created and then the deployment's created, regardless of if these are in two different files or different orders or whatever. It understands that there's a dependency on one another. So switching gears, the state. So the whole thing is giving us this powerful three-way diff. It has to live somewhere, right? So by default, it just creates a file on your local machine, which works great until it doesn't. It's typically better to put it somewhere else because if you want to work with anybody else, they're going to need that state file to run when they want to update stuff. Similarly, CI has the same problem. It's good to back those up because if you have a really complicated state, it's going to take a while to find all the IDs and rebuild it, basically. And there's some security concerns because the state can contain sensitive values depending on what exactly you're doing. So it's not the best to leave it laying around on your box. So let's take a look at how we can set up a remote state. So there's a whole bunch of options, like everything. We're going to focus in on an HTTP backend. GitLab, in fact, provides this with every project you create out of the box. So to configure that, we would go ahead and define our backend as HTTP. Inside those braces, you could define all the values. There's, again, a million ways to do this. If you go to your GitLab project, it will actually give you all the commands you need to run. So you literally just run these. Excuse me. They have a GitLab command line tool that you can use that just automates this process. But either way, you can copy paste and it works. So let's assume we have that set up. That means we have an empty Tofu stack that has nothing in it, but we have a state backend for it. So let's go ahead and add a provider, like we talked about. In this case, we're going to actually add the GitLab provider. Let's go ahead and configure it. So we have to point it at a particular GitLab instance. Every provider has different requirements, and we need to give it some sort of API token so it can actually do something. And there's a bunch of ways to do that. So assuming we have that, here's an example of a data reference. So you could imagine that your company already exists. Somebody else has already set up a GitLab project, and you want to just create something inside of it. So you can go ahead and say, hey, go look up the GitLab group that's company 1, department A. It'll find that for you, and then it will pull down it from the API, and you can reference things like the ID. So now I can say, OK, create a resource, a new GitLab group, inside of that other group that you just looked up. So it's a child group. And then we can go ahead and say, create a project in it. So just kind of a simple hierarchy here. Again, it understands that those need to be done in order, and you end up with a GitLab project in that hierarchy that you can push to. So it's fun because you can manage all sorts of stuff. You can manage GitHub accounts. You can manage email servers. You can manage all sorts of random things. All right, so our goal was Kubernetes. So how do we do that? So again, starting with that state backend, let's go ahead and add the Kubernetes provider. Again, has configuration. Looks different than the last one. It's going to be platform specific how you get these values. But effectively, it has authentication and a host cluster that you're pointing to. So assuming you have that, boom, you get access to pretty much everything in the sun. You can make namespaces, deployment services, ingress, all that kind of stuff. So we'll walk through some of those. Before we get too far along, though, we're going to have to introduce the concept of a variable, exactly like you'd expect from every other programming language. The neat thing here is we can define a default. So you can imagine if we were making a namespace, we're going to probably want to deploy our application to multiple environments. You can imagine a prod, a stage, a review, all those kinds of things. So you're going to need some way to change the namespace that's deploying to. So in this case, we say we're going to create a namespace that's the var environment -app1. So we can control that. When we apply, we can actually pass them in directly. So you can say like, hey, I want you to apply to production this time. There's a billion ways to do this, like everything, just giving you some ideas. You can put files in the same directory that contain it in different syntaxes. You can also set them as environment variables. And you can even do it statically. Sometimes it's helpful. You can actually make different directories here, like prod, stage, and your app module. And you could just instantiate it with different values. So there's like a million ways to do everything. And they all have different advantages in different scenarios. So similar to a variable, we have what's called a local. It's basically just a variable that you can't pass the value in from the outside. It's helpful for kind of consolidating or making some of your internal workings a little bit more concise. So as a very simple example here, we're creating a namespace and a cluster role. They both have var environment and the local name, so we're just avoiding repeating app1 in case we ever want to change it. Obviously, we're also repeating the name there that's sticking them together with a dash. You can pull that into a local, all the stuff you're probably used to doing programming. So getting back to our deployment here, if we want to deploy the image, you're going to probably want to change it. You're going to have a prod version or an old version, or you just built a new one, so you need somebody to control the image. So we pull those out as variables. You can pass them in there. You can see here abbreviated Kubernetes deployment resource has the image and then a tag that we're passing in. I like to pull out the labels here. As you saw before, the labels are how everything keeps track of everything. So rather than accidentally typo, I like to pull them out like this and just stick them everywhere. Then you don't screw it up. So similarly, we have a service here. So that was how it's finding the pods. There's a selector. So you're kind of repeating this stuff around. But you can kind of see how having a little bit of these variables here and whatnot is a little bit more flexible than, say, YAML files or something else. Just to show you an example of how easy this is. So you've probably heard of auto-scaling. And Kubernetes has a built-in horizontal autoscaler. So in this case, we could say that our service in production, we want it to have a maximum of 10, minimum of 3. We want it to target 30% CPU, and we list the deployment that it should scale. And what that means is it will pay attention to it, and if it hits 40, it'll spin up another pod, and it will keep trying to make it sit right there at 30. So it's literally this easy. You need to have everything set up, but it works.
So the advantage of that is that if you're like doing this straight up Kubernetes, like in YAML file, you could put like a conditional there that you can, like mirror and max.
Yeah. There's kind of that routing. I mean, there's some things you do with YAML, and obviously the package managers that are out there have their own like templating syntax they use on top of YAML. So like Helm basically keeps track of all the resources with labels and stuff. So it's not doing a three-way diff as much as it's like finding them again. So like, yeah, there's different approaches, but this is nice because it makes stuff a lot more reusable and whatnot. So let's see here. So the other requirement we had was being able to get a Sentry DSN, just another one of those minutia things that you have to set up. So similarly, we have a Sentry provider. It needs a token. Most of the time when you set stuff up, you're going to want to have some source of truth that has all your secrets, wherever that is. It could be AWS Secret Manager. It could be something else. In this case, you're going to use Kubernetes. So we already have a way to connect to Kubernetes. So we're going to say, hey, give me the value out of that secret, and then I want to pass it into this provider because I need this value locally or wherever this tofu is running, right? So then you can see, again, we can use a bunch of data references. We can walk through there and say, look up the organization, find the project, give me the DSN off it. Same thing we can do with a bucket. We can create our AWS S3 bucket here. Just kind of showing you like we can tie all these together. So now we're bringing it all back into our Kubernetes deployment. So I can actually set environment variables directly on the deployment for the Sentry DSN, which is referencing that chain of Sentry data objects we created, and then the bucket we created. So after it finishes creating that Amazon S3 bucket, it will go ahead and give us the ARN and just stick it right there in the environment variable for our application to find. So it's kind of a neat way that you can chain all this stuff together. Simple example here just to show you can do more complicated stuff. If you're running an application that's not public, you're probably going to need some sort of credentials to pull the image down. You're going to need something like this. So we're actually doing a JSON encode, base 64. They have a whole bunch of functions to do all the stuff that you're used to. So you can do more complicated things than just kind of like static stuff. So assuming we got all that stuff set up, so we can deploy our application with Tofu. The next thing we want to do is automate it because we don't want to explain to anyone else how to do this or risk them passing the wrong variables or screwing something up. Let's see here. So for our purposes, GitLab has all kinds of stuff. We're going to focus on the Git repository and the CI component. So basically all we want to be able to do is say, when we push code, I want to run some jobs. And what's a job? Just means I'm going to run some commands in a container. And they use the term pipeline to refer to a collection of jobs that can also be ordered like a dependency chain. So our goal here is we want to be able to build and push that container that we looked at in the beginning, and then we want to be able to deploy our tofu stack to 3 different environments. Preferably, we like a review environment that is ephemeral, meaning we can create it whenever someone makes a MR, which is their term for a PR, and destroy it whenever they merge it kind of thing. So come up and come down. And if you're curious, GitLab has a whole bunch of like auto DevOps and components, which you're probably more familiar with from like GitHub Actions and things. I'm going to show you the way to do it without those, just so we can kind of like walk through and understand how it actually works. So we're going to use GitLab as a concept of an environment, which you can give it a URL, which it just displays in the UI for you in various places. So it's a really nice convenience. The main thing that we're after, though, is the life cycle. So it can give us certain events that will trigger it to stop, and we can react to that. So the events we're after is when you merge the merge request, if you close it, or maybe you just leave it open way too long and we don't want to keep the resources hanging around, so we expire it. So let's take a look at what a GitLab job looks like. So again, we're just giving it a container that we're running in, so the same one we've been using all along, and we can run all the same commands like we normally would. GitLab has this concept of a stage. They default to having a build, test, and deploy stage. All it means is that the jobs in each stage wait for the jobs in the previous stage to be done. You can override this behavior, but just something to be aware of. So let's go ahead and build our container. So we're running that same buildx command we were running before. We say let's go ahead and just use a Docker container because all we actually need is the Docker command line. There's a little more to it. I don't know if you've ever built an image in an environment like this, but you actually need something called Docker and Docker most of the time. Again, this is nuanced. There's other stuff, but kind of a funny idea to think about, Docker inside of Docker, but that's what you need. And then similarly, the deployment. So we'll assume there is no image OpenTofu, but just placeholder for this. But then basically you want to be able to run the init and apply command. And then here's what that environment looks like. So you're saying, hey, this job is actually going to deploy something that represents the prod environment, and it's going to be accessible at this URL. So if we want to have those review environments, we need some way to come up with a unique but non-clashing URL. So the bare minimum simple one here, I'm going to use the merge request ID. Some people like having parts of the branch name or people's usernames or other stuff in them, but then you obviously have to be careful they don't clash. So we're going to stick with simple. So then we need to add here what to do when we want to stop this environment. So we say, hey, go run this deploy stop job that I'm naming here, which is going to do everything. It's going to init tofu and all that stuff, and it's going to say, hey, tofu destroy. And then we're specifying here that it's manual because we don't want this to actually run, because otherwise we just destroy our environment every time we create it, which would be kind of pointless. So manual simply means that either GitLab's going to trigger it or you're going to go find it in the interface and click the I want you to do this button. So this is kind of just how you tie all those together. So what does this actually look like? Go ahead.
You're saying the GitLab server is going to destroy it in 5 days, or you have to?
No, GitLab will.
GitLab will automatically after 5 days when you have it. Okay.
Yep. Yeah. So like places that I've worked, we obviously have tons of these review apps, and they eat a lot of resources. So if nobody's looking at them after 5 days, they're probably worth getting rid of. They can always relaunch them again. So what does this look like? So you're probably familiar with what a PR looks like. This is an MR, basically the same kind of interface. The important part for us is that at the bottom there it says deploy to MR-1, because that was the environment name we gave it. And there's that view app button, which will link to the URL we gave it. So if you're the developer and you're pushing some changes, CI runs, it deploys your review application, and all you have to do is click the view app, and boom, you're into your review application. So it's a pretty neat way to hide a lot of the complexity. If you clicked on that MR1, you can actually see the deployment history for those environments. This is more useful in something like production if you want to see when people are changing stuff. But you do have kind of this little bit of meta information that you get from having an environment. Again, important to us, it's very hard to read, but in the top left it says this is going to auto stop in 3 days. So you know exactly how much time you have left out of the 5 days. And you can actually pin it to prevent it if you wanted, but there's just some nice stuff. If we clicked on the job from here, we can see the logs from CI. Probably used to seeing these kind of things in different CI runners out there. So in this case, you can see we're running Tofu. It's pulling down all the providers, running the apply. At the end of it, you'd see something like this. It says, hey, I created 7 things, which would be things like our namespace, our deployment, our S3 bucket, everything. Again, hard to see, but this is the K9 interface, so we could go into Kubernetes and say, hey, look, it's actually running our pod. We can see the logs from it. It's all there. We go into AWS. We see our bucket got created, MR1, da-da-da-da-da. We go into Sentry. We look up the DSN we're expecting to be there. So just to recall then, this was our really trivial application here that's just going to print out the values of those environment variables. So if we were to curl this application, you would see that everything got tied together and it's set up the way we expect. So what Tofu is actually doing there is just creating that bucket, pulling the yarn off of it after it's created, sticking it in that environment variable on our deployment, similarly with the Sentry DSN. So it's kind of mapping all that together for us. Kind of fun to look at, but this is the dependency graph for our very simple application here that Tofu is actually following. So it's actually starting from the bottom there and doing these all in order to get this to work. If we zoom in a little bit, I didn't show you this part, but I have var cube, which is basically just my Kubernetes credentials that CI has available to it. And you can see it's starting with that, initializing the Kubernetes provider. From there, it's grabbing those two secrets. I showed you the Sentry one, but there's another one for AWS that have those tokens in it. It's initializing those providers, and then it can go do those things and eventually come all the way back around to creating those Kubernetes resources. So you can see why it's very important to have this, have it kind of just handle this dependency graph for you, because stuff can get fairly complicated fairly quickly. All right, so it works. Of course, no point in waiting around. Let's ship it. So we go back to our MR, click the merge button. Boom, it triggers the stop job. You'll see it said it destroyed everything that it created before, so we got no mess. In our merged branch in main, I didn't show you this part, but you can see that we deployed to stage, and we have a button there where we can trigger the production deploy. So if we were to go ahead and click that, it would run, and boom, we'd have production deploy. It'd be that easy. All right, so it's a lot of stuff, but we're not going to stop there. So this is the part where I said we're going to peek under the water a little bit of the iceberg. So we're going to, we got it working now, but we could always do better, right? So we can make it faster and more reliable. So we're going to look at a few things that we might be able to do. So kind of a summary of what we have in CI right now is we're building and pushing container. We have to init our Tofu stack and then apply it. And then just as a third piece, there's job provisioning that's going on. So all the stuff that happens around those jobs to get to the point that we're actually interested in. So we'll start there. These are kind of like the top level steps here. Unless you're running your own CI, we can't really do much about the first two. So we'll focus on the last three. So pulling down an image, one of the things you'll notice in CI, and you're probably familiar with, is you get those periodic, like, hey, some network thing timed out or whatever. Like you're doing a whole bunch of steps serially in CI, and if one of them fails, the whole thing blows up. So the less of those calls that we can make out to the internet, generally the more reliable it is. So a lot of CI providers, including GitLab, have some sort of way to proxy all of your container pulls. So they're internal to wherever they're running the CI, so that you don't have that network hop, and they're generally faster. So this is as easy as putting a variable in front of our image, and we're done. So that's nice. Something to pay attention to is, do you actually have to clone your entire repo? Some CIs do, some don't. GitLab happens to default to 20 on new projects, so it's a shallow clone, 20 commits down. So generally that's pretty good, but just something to be aware of. So let's move on to the execution. So our deploy job, if you zoom in on the logs here, you can see the last few lines there. It's actually installing all those providers, which again means it's reaching out to the internet, going to some registry and pulling them all down. So that's, again, another place for reliability problems and wasting time. So Terraform, like pretty much any other package manager, has some sort of lock file. So this just describes the current version and hashes of all the providers that we're using. So we can actually use that as a cache key, where we say basically like, let's store everything that's in the Terraform directory. We will cache it based on the state of all of our dependencies. And then when we run the job, you see it now says we're just using them, we're not installing them. So we just got rid of that entire network hop. Everything's internal to whatever CI cluster you're running it in. Which is pretty slick. So the next thing we'll look at is Docker build context. So something that's kind of like, go.
Back with the product build, is there a way to restrict that in case like it's not your main branch, you had an image that you're deploying?
Like triggering that job, you mean?
Yeah, like, I don't know, you just have it there, and you wouldn't want to accidentally deploy like your stage image to the prod, right?
Yeah, you can. I think GitLab and GitHub and a bunch of the other providers have different approval concepts that you can slap in there of who's allowed to basically trigger those manual jobs. You could also have credentials set on the like Kubernetes cluster or the deployment target itself, and people would have to have a way to provide those to it when they trigger it. Like, yeah, you could definitely restrict it in different ways. But let's see here. Okay, so going to the build context, so something that's kind of magical that happens whenever you run Docker build is it actually transfers all of the files in your current directory to its daemon, regardless of what you actually want to use. So it's just kind of a magic performance hit that you can not always notice. So like in our example here, if we were just saying I want to copy everything in the source directory into my image, when you run buildx build, as soon as you do that, it's actually going to copy everything in the dist folder, everything in the node module folder, everything in the source directory, which obviously can be slow depending on how much other stuff you have laying around. So you can actually trivially ignore that. Same syntax you'd have like git ignore or anything else. So you can say, hey, I don't actually want you to pull all that stuff in. I prefer doing an allow syntax. So you say ignore everything except the stuff I actually care about. It tends to be a little easier to maintain. But that'll cut down, you'd be impressed, 30 seconds to even a minute off some builds, depending on how much stuff you have laying around.
Can you get the Docker to ignore based upon your Git ignore?
Based upon what?
Your Git ignore?
I'm not aware of that. They end up looking very similar, though, not always exactly the same. The question was, can you use the Docker to just use the git ignore? I mean, you could also just put a copy command before your build in CI or something like that. But yeah. So something to understand about containers is that they're basically comprised of layers. One of the tricky things is if you put a file in there and then the next command you delete it, it's not actually gone. It's still in the layer underneath, and all you did was mark it as not there anymore. So you need to be kind of careful what you run in different layers to avoid bloating it. And another thing to kind of pay attention here, which I'm trying to demonstrate with these blocks, is every time you have to reevaluate a certain layer, all the layers after it also have to be reevaluated. So ordering becomes really important here. So you can imagine the copy step on the red block. Anytime my application changes, that's going to be invalidated, any file in there, because I'm copying all the files in, right? So as soon as I do that, it's like me taking the red block off. I therefore have all the green and the blue block off. I have to put the red one back on, then the green one, and then the blue one. So ordering kind of matters there. And any image that you pull in, like Node, they're just going to have layers underneath there, so you can kind of think you're just building this stack of layers. Another thing to keep in mind is like not all layers are the same. So some layers are going to take a long time. Some are like milliseconds. So kind of picking and choosing. You generally want the things that change the most at the end. So going back to our very simple Docker build here, as I just mentioned, the copy statement there is invalidated anytime you change any file in the directory at all. So the next line directly after it is actually installing all the dependencies. So if I change my main.js, boom, I got to reinstall all the dependencies again, which is not ideal. Very easy to fix if we were to move that copy line down and instead only copy the bare minimum that we need to actually install the dependencies, which turns out to be the package.json and package log file. We put them in that order, then we'll actually only ever invalidate the dependency layer whenever we change those files, which is usually when you're changing dependencies, but obviously there's other things in package.json. So again, this is pretty good, not perfect. Another thing that you hopefully are familiar with is if you install npm CI or any install, there's two kinds of dependencies, right? There's the runtime dependencies effectively and the ones you need to develop, which can be compile ones or tools or things to run tests, whatever. Again, that all tends to bloat out the image because you shouldn't need any of that at runtime. Otherwise, it probably isn't a dev dependency. We can go ahead and omit those when we install it. So then we ignore the dev dependencies and we only install the other dependencies. So again, as I said, you can't delete files in layers. They're always in the lower layers. So in order to take advantage of that, one of the common approaches, you can also just do a whole bunch of stuff in one step, but is a multi-stage build here. So we take what we had before, that's what's at the top there. We say as build, which just means that that won't be the final container. This is some intermediate step. So now that intermediate container is walking through, doing all those things, installing the dependencies, transpiling, and then you'll see the second from there, which actually starts all over from a node-based image again. Says only install the dependencies without the dev ones, so only the runtime ones, and then we're copying the transpiled result from the build container into our final container. So this avoids having the source files end up in your final container and all the dev dependencies. So you're getting a kind of a lean, mean container here. Of course, the fun part with being really optimal with how our layers and everything are set up is that you're not getting a lot of performance gains unless they're actually cached. And the only way they're cached is if they're present when you're building. When you're doing this locally, they're going to be sitting there all the time unless you clean them up, so it works great. So it can feel really good. And then you push it out to CI and you realize CI is starting from scratch every time, so it doesn't matter how pretty my file looks, I have to run everything. So in order to fix that, you can add these cache to and from flags. The simplest way is this inline version here, which basically says add a little bit of metadata to the image that I'm pushing up so I can use it as a cache point for next time. Back in the day, you would have had to pull your images down for them to be present at build time, which usually was a waste because if you weren't able to use certain layers in there, you still had to waste time downloading them. Now with BuildKit, it's really efficient. It pulls the metadata down. It says, hey, whatever layers I'm not changing, let's download those and we'll ignore the rest. Pretty slick. The downside of doing this is, if you recall our multi-stage build, in order to cache the first part of that multi-stage build, we obviously have to have all those layers. So now, instead of just having that final build result, by putting cache to inline, it has to include all of those layers that we were trying to get rid of. So the workaround for that is you basically cache it as a totally different image. So you see there, I'm suffixing it with -cache, and instead of doing inline, we're saying it's a full registry image. And so what this does, you actually end up pushing two images. You push the one that you actually want, and you push this image that you only use as a cache image for building. And if you know anything about registries, they're pretty much all designed that if you end up pushing the same layer like 3 times in 3 different images, you're not actually pushing the whole layer. It understands that it's the same one. They're all hashed and everything. So it's not really a performance hit from doing this per se, other than you're obviously uploading the extra layers for the cache. But oh, that was the other thing I was going to say. So probably not super obvious because it's a fun named variable, but that CI commit ref slug, what that is actually a cleaned up version of the branch. So you can imagine in this scenario that if I was running on the main branch and I fork to feature 1, and then this runs in CI, obviously there's no feature 1 cache because I just made it. So it's going to have to run the whole build again, which sucks. The next time we run, it wouldn't do that. But we can fix that by saying, hey, let's actually cache from the main branch as well. So now I can look at both of them for layers. So the first time we run this from our feature branch, it will actually use the layers from the main branch. And the next time it would use our layers, or whichever ones are convenient for it, basically. So that's nice. But of course, can we do better? So right now, with what we have, we've basically limited the scope of our layers and when we have to rebuild them. So it's pretty good. The problem is, anytime we invalidate one of the layers, we still have to rebuild the whole thing. So if you add 1 dependency, I have to rerun that entire npm install step, which means every single dependency has to come down, even if all I did was add 1. Similarly with the build. So really what you want to do is you want it to be incremental, right? You want it to behave the same way it behaves on your machine. If you add 1 dependency on your machine and you still have all the ones there from last time, it's only going to download 1. So we kind of want to recreate that same behavior. So if we look at our multi-stage build here, the last step is going to remain the same because all the fun that we want to be incremental is in the top there, the npm CI and the npm run build. So focusing in on that, we want to pull out those 2 commands because we want to figure out how to make those incremental. If we pull those out into our CI job that was doing the build here, so we're running the same image that we were running in that multi-stage build, we can actually attach a cache and say, hey, I want you to cache the dist and node modules directory keyed based on the current branch. And now that means they'll always be present there. So like if you're running in your feature branch and you add 1 package, it's only going to download 1 package. And then the actual image build, once again, becomes the second half of that file. And the only thing we have to change is the copy from build changes to copied out of the current directory. So that's pretty cool. The downside is, once again, as soon as you feature branch, obviously I'm not going to have a cache key for feature branch. So we can add a fallback key. Works exactly the same way. You'll see this pattern repeated in all sorts of things, where basically I'm always falling back to the main branch. So that's pretty good. We can be incremental almost all the time. There's, as usual, nuance to it. The only thing we're left with is some cache overhead. So everything we put in the cache obviously has to be set up and torn down every time. But it's pretty good, and it's generally going to be better than leaving it not that way. So to recap, hopefully we picked up some stuff about Kubernetes, some of the kind of like areas around the bounds of this topic. And then we managed to deploy our application to Kubernetes, keep track of everything as infrastructure as code, and automate it in CI. So that is the end of the talk. And then if you're curious why I know any of these things, way back when in 2008, 2009, I built basically a CI system from scratch. Kind of opens your eyes to how the heck it all actually works. And from there, pretty much any company or place that I've worked at, I end up trying to tune everything because I'm very familiar with how to do all those things. You see all the same problems at all the different places, all the same tricks, and all the same diminishing returns fighting the cache, which led me to start Cedar CI, the sponsor of the talk, to try and optimize all this CI stuff as much automatically. As you saw, we were playing around with cache keys there, so I eliminate the cache keys entirely because there's a lot of things you can do better with that, and try and get rid of the overhead from caching. So 'cause the thing you end up doing is every time I add something to the cache, it gets slower. So if I save 30 seconds of build time, but I add 20 seconds to the cache, I save 10 net. So really, the thing you're always fighting is the cache overhead there. So a lot of times, as I said here, I have some benchmarks. You can make stuff 2 to 10 times faster, so that's my spiel. I write about a lot of these topics on the blog, so like the details of how that Docker building and all that stuff works. Copy of these slides available in the second link. And I have a full-blown example. So we obviously had little slices of all the Terraform and the code and everything. I have a full-blown example in a repository that you can pull up that contains everything in a workable form. And I also have a Cedar CI branch, which shows you if you really want to have fun. You can tweak it a little bit to really get the most out of it. So that's it. Happy to hear any questions or reactions or anything like that.
Can you go back 1 slide?
Sure. All right. Guess that's it then.